Hi guys, we back with another one. So today I want us to look at the emitter bias BJT transistor, specifically also dwelling into the input and output equations. So first of all, must be able to draw the circuit itself. So once you hear emitter bias BJT transistor, you must be seeing a picture in your mind. So what picture do I see? It's more similar to the fixed bias, but it has a biasing also on the emitter section. It's the same thing as the fixed bias, but the only difference is that it has a biasing, it has a resistor on the emitter. Let's draw that. So it's gonna be like this. That VCC section, then those resistors which we have, and then let's have that section where we have our transistor itself. Then there, the difference is right there. And then grounding. GND. So that's the circuit, how it looks, the emitter bias circuit. So we need to do the same thing, casualties. We must highlight our nodes, very important. So that node there, and that node here, very important. And we have another node there, and we have another node there. It's gonna come in handy. And then even there. Okay, so we agreed that the right, it's I'm gonna have my input, and the left, it's why I have my output equation. If you don't agree, go watch the previous video on the fixed bias first, and then you'll see what I said there. So you're gonna be looking at the left side, but the problem is that there's no leg here. So when we get here, we must turn and come here. So very important. Let's try and introduce the input equation. So the input equation, right? But now let's label also even here what we have. So you can all agree with me. You can agree with me that this is RB because it's on the B section. This is RC. And then here it's RE. If you don't agree, go watch the emitter bias video, please. And then this node here is node B. And this node here is node C. And this node here is node E. Right? Because it's the B is the base section, collector section, emitter section. Clear. Now let me deduce the left hand side, what I'm going to be adding in the left hand side. So let's try and have that. So I'm going to have this voltage here, and I'm going to have my little voltage here, and I'm going to have also my little voltage here. So I have three sections now. So I have this voltage here, this voltage here, this voltage here. And what I know that adding this voltage, and that voltage, I must get VCC. Now let's find my labels. What are my labels? So here I would say it's VRC, sorry, not VRC, but VRB. And then here I would say it's VBE, because from B to E section, right? And then here I would say it's VRE, because it is the voltage of the RE resistor, right? Let's continue and find it. So it's gonna be VCC equivalent to VRB plus VBE plus VRE. Remember what I said? I said we want to have IB always as our substitute formula, right? But most importantly, you must know what is the three very important equations of a transistor, right? You must know, actually it's three, but I'm going to use two now. You must know that IE, let me use a different color. IE is equivalent to IC plus IB. Agreed? So those two, when you add them, you're gonna get IB. And then you must know that IE is it's IC is equivalent to IB multiplied by B, right? And then after that, we're gonna go into our expression, the original one, and we're gonna take this into that equation. Very important when you're trying to create this expression. So we're gonna substitute IC because when I have everything on the right hand side as IB or having IB, each and every term must have IB. So we're gonna have IE being equal to, substitute this into IC, it's gonna be IB beta plus IB. And then we're gonna notice that we have a common factor, we can take it out. Therefore I have IE is equal to IB open beta plus 1, right? So this is what I was looking for. This will come in handy when I'm gonna be solving that expression, because remember I want to have IB somewhere somehow. Now let's continue and solve that expression on top. So let's expand that. So we're gonna have BCC is equal to VRB, we can break it down to IB RB, then plus VBE, but this one it will be RE and then IE, right? But oh, thank Lord, we have IE here, and you know what IE is. So wherever we see IE, we're gonna substitute the value of IE. Therefore, it's gonna be VCC is equal to IB. But just to make things simpler for us, let's take VBE to the other side. So it's gonna be minus VBE is equal to IB RB plus RE into brackets IB into beta plus 1, right? Now let's take out IB there. So it's gonna be VCC minus VBE is equal to IB into brackets RB plus RE into beta plus 1, and then close those big brackets. And hopefully you're keeping track. Now remember I said always our input equation, the subject of the formula has to be IB. So we're gonna make IB subject to the formula. I'm gonna remove that so we have some space. So therefore IB is equal to VCC, I'm dividing both sides by whatever is in the brackets, the big brackets, minus VBE divided by RB plus RE into beta plus 1. There we go, we have our input equation. That is the final input equation. So let's try and find the output equation. Let's go and attempt and find it. Let's attempt and find that input equation, the output equation. Sorry guys, let's attempt and find that output equation. Okay. Okay. So output equation. Now we'll do the similar thing. Let's erase this. We don't need it anymore, the green stuff. Now remember I said for input equation you're going to look at the left hand side. Now for the output equation we're going to look at the right hand side. Now let's go and highlight those sections. So we're going to start by this section here. That's where we're going to have our first voltage distributed. Then we're going to have to this section here our second voltage being distributed, and we're going to head to that section there, our third voltage being distributed. And if you check, I am putting my green lines right where there is a connecting from that dot to that dot, from that dot to that dot, from the next dot to the next dot. So have that logic so that you see, and because remember we're doing electricity, so we can't really see electricity, so you need to use your imagination. And yeah, but let's continue with this one. So meaning that this voltage here, when you add it, it must add up to VCC. Therefore we can say that VCC is equivalent to VRC plus VCE plus VRE, right? Now here is a very, very important section. Very, very, very important section. Before you go further, you have to declare this, that IE is approximately equal to IC. You have to always, when you get to this step, before you go any further, before you expand, you have to say IE is approximately, let me actually make sure that the E is visible enough. Yes, IE is approximately equal to IC, because the difference is not that different, that big. So we're going to continue and expand this and this. Therefore VCC is equal to IC RC plus VCE plus VRE. Now let's take this onto the other side. Therefore VCC minus VCE is equal to, therefore IC RC, and then let me change this one, plus IE RE. What is IE? It's IC. VCC minus VCE is equal to ICRC plus ICRE. Therefore we can take a common factor. VCC minus VCE is equal to IC into RC plus RE. Now let's conclude it. Remember I said that a VCE must be always the subject of the formula. Therefore I can say that my output equation is VCE, let me write it with a different color. Therefore VCE is equal to VCC minus IC into RC plus RE. And that is my final output equation. Very important. Thank you guys. Cheers, and sorry for having the video long, but I want to have a thorough explanation into it, a bit of some depth. But yeah, cheers guys. That's the output equation. So this is the final output equation.